Chapter 1.3, the scientific method. The scientific method is a systematic approach to research. Whether you're a social scientist or a physical scientist as a chemist, the scientific method is an essential part of all research. The base of all science is collecting data. Data consists of two types. Qualitative data is the type of data that consists of general observations about a system. For example, in a chemical reaction, if you were watching the chemical reaction and you noticed that it turned colors, or that gas bubbles were forming, or that it was getting hot, all of those would be qualitative data or observations that you saw during the reaction. Quantitative data is comprised of numbers obtained during measurements. For example, in a chemical reaction, if you collected the mass of a product that was formed, you would have a quantitative data. They are physical measurements that are made during the lab. When carrying out scientific research, there are several steps that need to be done. The first step is to ask a question. If there's no question to be asked, there's no reason to be researching. For example, if we wanted to study the effects of listening to music while studying for a test, our question may be, what are the effects of music while studying for a test? Once you've formed your question, the next thing you have to do is do a little background research. Background research is to see if there are any studies been done, any previous knowledge exists about it, your previous experiences, friends' previous experiences, all of that is considered background research. So in our example of listening to music, we might want to do a little background research to see, has anybody studied the effects of maybe listening to country music versus rap music versus R&B versus contemporary versus classical? All of those might be independent background research that can be done. Once you've done your research, you next need to construct a hypothesis. Your hypothesis is your statement of what you believe is going to be found as a result of the research. It is not always true. It does not have to be correct. In fact, most of the times, our hypotheses are not completely correct. Once you form a hypothesis, you should devise an experiment. To test the experiment, you need to collect data. Observations need to be made, both qualitative and quantitative data. Quantitative data should be made. We would, in our experiment, if we were devising a listening experiment, maybe we have to set up what kind of things we're going to test. Are we going to test a random sample of people? Are we going to test different varieties of music? Are we going to test how they memorize elements, symbols? Are we going to test how they memorize a set of numbers? Are we going to test how they memorize a set of facts or digits? All that is part of developing the experiment and testing the experiment. Once the experimentation is complete, you need to analyze the results. From the results, you can draw a conclusion. And one of two things is going to be decided. Either your hypothesis was true or your hypothesis was not true. Either way, the results can be reported. A false hypothesis is not a bad thing. A false hypothesis, although it may not give you the results you were looking for, sometimes can lead in a great direction for another research project, or can lead you to change your hypothesis and retest your experiment. A true hypothesis is fine as well. If the hypothesis is true, that means that what you suspected all along was what was happening. Once you studied and you formed some results, it leads to the formation of either a law or a theory. There's a big difference between the two. However, a lot of times people use them interchangeably and they think they mean the same thing. They really do not. A law is a concise statement about a relationship that is always the same. The key there being is always the same. For example, in physics you learn that force equals mass times acceleration. That is a law. Every time you measure mass times acceleration, that will be force. Every single time. A theory is a unifying principle that may explain the facts that you found in your experimentation. For example, Einstein came up with the theory of relativity, which says E equals mc squared. What he hypothesized and what he theorizes based on his research and based on his experimentation and based on his studies is that as we approach the speed of light, energy becomes exponential and time stands still, in other words. So it is something we cannot test. We have theories based on it, but it is something that cannot be proven as absolutely true. Another theory that's very controversial is the theory of evolution. Whether you believe it or not, I'm not influencing you either direction. The theory of evolution is just that. It is a theory of how mankind developed. There are other theories that exist. The word theory in itself simply says, based on some observation, based on a body of facts, this is a logical explanation for what we see. All in all, the scientific method is essential to everything we do, and throughout the year we will be following many, many scientific experiments, and they will all follow the scientific method.